And we're back. Welcome to our second special ship week episode. Not so easy to say. I can easily lose my PG rating if I get that wrong. Let's pray. Dear God, thank you so much for today, for just the extraordinary opportunities I have here, even if things go up and down emotionally. We thank you that you are faithful, you are consistent. Thank you so much for the chance to partner with Daniel in this amazing work. We pray that we would be like Nehemiah, that we would keep one eye with a shovel, one hand with a shovel, one hand with a sword, and both eyes firmly fixed on you, and not turn aside from the great work you've called us to. I ask this in Jesus' name. Amen. All right, so I've had an amazing lunch with Amy, giving her a brain dump on everything going on. And the metaphor we're using to describe the Swan Factory to Christian investors is that we want to do to software what Chick-fil-A did to fast food.
All right.
In creating a revolutionary experience with unusual values that builds a devoted following.
Cool.
So she actually knows somebody at Chick-fil-A who might be a potential investor.
Awesome.
So I figure that's actually a great test of whether we can explain what we're doing in a way that non-technical people can get excited about.
Mm-hmm.
And in fact, we actually had a huge breakthrough. I went through the exercise we did today, you and I did on the last episode, where I walked her through David's level and then the different ways to solve it. And she went through the exact same steps we did. Well, why can't you just brute force it? I said, well, then we have these constraints, and then, well, but you can turn like this. Oh, wait, but no. And so and then I say, this is the clicks and the ticks and the bricks. She goes, oh, I get it. And I said, well, isn't this what everyone does when they learn software? I said, no, you have no idea how bad it is. So that was good. I feel like that was a huge breakthrough.
Good.
So did you want to go over any code or just dump right into the waffle stuff?
Well, yeah, there's a few code things I would love to go through. If you want to open up my most recent pull request.
Right. So I actually have no idea how to open up a pull request on a branch.
Oh, you know, actually, I'm sorry. I don't have a pull request open yet. All you want to do is open the branch.
So which branch and where do I open it? On the browser or in the terminal?
So just open it up in the browser because it's the easiest way to visualize it. If you open up the Hour of Node repository.
Let's see which. Yes, okay. Hour of Node. There we go. And then branch.
There's a branch.
Limit sequence size?
No, collision engine, actually.
Okay, the one we were working on before.
Yeah.
Okay.
And then click on that green button where it says compare, review, create a pull request.
Ah, thank you.
I'm not ready to actually create a pull request yet.
Sure.
But, you know, I made a few commits to it, so it's actually working.
Okay, we should probably one of us should share our screens. I guess I have it up, so I'll share mine. And actually, I can even cheat. I can share the actual window since I'm not doing coding. Even better. All right. So you want to walk me through this?
So, I mean, minor changes really that I did. We had basically written the code, and I was satisfied with its functionality by the time that you left. I mean, if you look at the two commits that I actually made, if you click on the commit messages, you'll be able to see what I actually did.
Ah, okay.
So there were some simple issues with...
the RX arrays versus regular arrays. Yeah.
Right. And then there was an indentation issue that was causing half of the code not to run.
Yes.
So really the code is basically working. The one place that I got stuck and just decided to move on and ask you about is, this has been the hardest thing for me working on this code base is scope and dealing with other objects. So we have a to-do note that we added. If you go back
to the original pull request,
we have a to-do that says, you know, we should reset the program counter somewhere.
Yes.
under our load program method, and I really am not sure what the best way to do that is. The program has a reference to the sprite in programs.coffee, but the sprite, I don't know how it should reference its program.
Right, and there's an interesting, yes, that is an excellent question. Just out of curiosity, have you done anything with the inheritable collisions, or is that still a TBD?
Still TBD.
Okay, that's fine. But that should be straightforward once we understand what we're doing, right?
Mm-hmm.
Right, so is there anything else you want to go over, or do you want to dive into this question of the program counter?
I think I'm happy to jump into this.
Okay. So, okay, because we can always get back to the waffling, the waffle Kanban later. So let's just take a look at the code and see. And when we look at this, we may want to actually do something. So okay. I don't know if I have your latest branch. So do you want to drive and I'll navigate?
Sure. I can only see your Chrome window right now. So you want me to share my screen then?
Yeah, I want you to bring it up in your editor and
okay.
Go through the code.
Let's share the entire screen. Okay. And
that's right, you're in Vim, right? Forgot about that. And can you click the present to everyone? I think that'll stop my face from showing up.
Sure. I don't have an option to present to everyone.
Do I have an option to make you a presenter? I guess I should just keep, well, I guess can't really keep my mouth shut either. So is there a way to do this? No. Interesting. Okay, Google plus fail. We'll just look at the code. Try and keep my mouth shut.
Okay, so sprites.coffee, we have this to-do note. Oh, you know what? I need to move back into that branch. Okay, so we have a to-do to reset the program counter, but we have no reference to the program. Programs.coffee, however, on the right side, the old method that we were using, the one that calls load program, is this. There's a collision method here that we were using previously, and this was calling reset index on itself, and then calling load program, which sets the running program on the sprite. So how do we reset the program counter?
Maybe to help both me and our viewers, could you maybe go over the programs file, where that's created and how that's created?
Programs file.
This file on the side there. Programs.coffee. Where is that object loaded from?
So programs is being loaded from behavior.coffee, being made into rows that look like these rows, which end up having all the actions within them.
Right, and the behavior object itself is loaded from the inspector?
Yeah, is loaded from the inspector.
right? And um, right, so we call make inspector world sprite. We create an inspector object which has a reference to the sprite, and then we have an inspector. We save that as an inspector property on the sprite.
Mm-hmm.
So in theory, I'm not saying we should do this. You could traverse the tree, inspector behavior program, and get all those things there. It definitely feels awkward to
So
do that.
from here, world, get inspector, find child, behavior, find child, program.
But that only gets us to the list of all the programs.
And then you would find child by, world.get.
Especially the key, right?
Right. Well, the old one.
Running hasn't been set yet. You do want to reset the old one, right? That was the idea.
Right.
So that is clearly a code smell.
Yeah, this is a pretty long chain here.
Yeah, so I'm saying that is the right wrong way to do it.
Right.
Okay, so let's think through why that's happening and where these things get set. And so let's go back to the programs file.
Okay, programs is on our right.
Mm-hmm. And what's interesting, so there's a couple things that are, there's a couple different things going on here. So let's think this through. The program behavior, let's actually go back to the top. So we have a list of programs that they're all created at the very bottom, correct? And I actually beat my head against this a while ago and lost. So let's take another run at this. Is that we have a list of actions. And actually, I realized for other reasons, this actions item here is, we call the keys method on there. No, I guess that's actually, right. So those are the actions defined in our game file, which is fine.
Right.
I'm sorry, could you stay down at the bottom of the programs.coffee?
Yes.
Thank you. And then for those contents, for each key, basically each word, we create a program row in our list of children's. I'm not sure why that's not just a simple map. That looks like that ought to be just a map rather than, oh, I see, we have to do it unless there's string contents. There isn't a trivial way to do a map where it, so what we're doing there, the reason we have the string contents, which may be worth a comment since even I'm not sure why I don't remember offhand, is that there are two kinds of actions. There's direct actions, which are strings that are interpreted directly. They're kind of SPI. And then there's arrays, which are sequences, which are visible and editable in the UI.
Mm-hmm.
It might be worth putting a comment in there to explain what that string test is for. Is basically don't let them edit SPI or something like that. If contents is a string. Yeah.
Mm-hmm.
Yeah. It is a primitive function or something.
Okay.
or only display it if it is a list of commands.
Okay.
Okay, then next it's only display if list of commands. Okay, then we create a program row, which consists of a bunch of columns. Actually, 2 columns, the first of which is the program name, and the second of which is a series of buttons.
Mm-hmm.
And we attach program behavior. So the buttons are just the contents, the command. This is just to do probably at some point, is that right now I needed some way to remove bricks I didn't want there. Mm-hmm. So I just did the simplest possible thing that could work, which is if you click on it, it goes away, which is probably not a really good idea because it's going to lead to a lot of accidental deletions, but it was expedient. We probably need either a confirmation dialog or a trash can or some other behavior.
Okay.
But that probably needs a to-do, like, add a dialog or something. Then, okay. Now, the way we do this, I'm creating this dictionary, which is the entire row. But I just realized we add the program behavior to the row rather than just to the program buttons. And most of that, and I think that's actually, that might be confusing the issue a little bit. So okay, now we can look at the program behavior, and I think we may need to refactor this a bit to make it more understandable and precise. So the program behavior, we give it the name as a parameter, so it knows the name. And the main things it does is it does something on tick, collision, and apply. We no longer do anything on collision, right? So
we're giving that to the sprite.
Right, so we can delete that for now to reduce our visual clutter. We do want to receive the apply event because that's where we store the action, if it's us. And then on tick is where actually the most interesting action happens. So when the clock ticks, if it is the selected world, get the next action and perform it. Yep. So tick is nice and clean. Next action is slightly less so. One of the things I always try to keep a clear sense of as an organizing principle is people should only mutate themselves. We shouldn't try to mutate other people. And so descriptive actions can go everywhere, but we should be very careful when we're calling things that create change. And so the next action, so actually I realized next action is probably an improper get. It really should be call next action because that's not just an idempotent accessor. That's actually a mutating behavior.
Okay.
Currently, there's actually 2 ways to solve that problem. Just to talk it through. One is that reflect reality, which is that when we call the next action, we also advance the program counter.
Yes.
The other way to do it is to get next action purely idempotent and either have a separate action that advances the program counter, but if we do that, then we would need to make sure that it's always valid, right? So right now, so I'm not saying you should do it. I just want to kind of talk it through what we're doing here. So the next action, oh, so you're just cleaning up the code there. So what is next action doing? So next action doing is, this is where it feels a little weird in that we're kind of mucking with the internal data structures. It feels like it would be more natural if the actions children kept the counter. Right. So right now, and I tried doing this once and I failed miserably. So maybe it's a bad idea, or maybe I just did it poorly. So next action looks to get the next in. So right now, so tick, perform, and apply. Those are happening at the program level. That kind of makes sense. But tracking the next index and the next action sort of happen at the actions level, if that makes sense.
Okay.
You see what I'm saying?
Mm-hmm.
Like, it'd be nice somehow if it was possible, and it may not be for reasons that I couldn't figure out, that next action should be saying, at worst, world find child actions, and then, actions call, it should be, return. It should be actions get next action, and then actions call advance index, something like that.
Okay.
Right, because then you have more locality. The tricky part is that you'd have to kind of do that by putting that inside the authority, and it gets a little complicated. The alternative is, could all of those live on the actions? Do we actually even need to? So instead of this being so if you go back to the bottom where we attach the program behavior to the program, what if we first created the buttons and we extended, so we have, buttons equals make buttons, whatever, before that, and then we have my extend buttons, button behavior, or my extend, actions behavior, and then we do program equals make columns name, comma, the label thing, and then the actions. So rather than making the program behavior at the top level, basically bump it down a level to the actions level, to the thing that makes the buttons. Would that actually work just fine? It seems like it ought to work. All right, we apply those to the actions, and then, but no, then the authority. So I'm not sure what the right thing to do is, but you kind of at least get a sense for the question I'm asking. It's like, who's maintaining the state? How do we attach the behavior closer to that state? There's a second thing that I have not been able to consistently figure out how to do yet, but I feel like it's important. And that is, loading a new program is an action, really. Right? Like, for example, it could be an action, which I've not tested yet. We talked about how, because we enforce chunking after 7 items, if you want to chain, if you want to do the brute force thing, you have to chain a series of events, which means you have to be able to create a new program, and then the last action of the previous program is to call that program.
Okay.
Right? And so that means load program would be a actual action. And in fact, if we go back to the perform, you see we have perform instruction and load program, right? Load program key and perform instruction are the two different behaviors. And it really looks like load program should probably be a actual method rather than a function. for consistency, and that should be the thing that actually, and it also should do the reset, right?
Yeah.
So let's actually talk about this. Why do we want to do? Why is it important to do the reset when we load the program? So if we get interrupted in a so I could actually, so all the programs we've done so far have tended to be either ridiculously long and fragile, right? They assume that no one's going to interrupt them, or ridiculously short.
Mm-hmm.
So it's actually an interesting question to me whether if you're interrupted, it's not clear whether you should go back to the beginning or just keep going where you were. So I just don't know.
Yeah, I know that when we talked about it last weekend, it was something that we had said they should definitely restart. It wasn't something that we talked about why they needed to restart or reset. We just said they did. So part of it the only program that has any chance of not resetting is the run loop, because all the other ones will run to the end and then return to the run loop. So the run loop is the only one that...
No, anybody can get interrupted.
Yeah. But they all return to the run loop.
So they will all right, the only one that's not going to be manually reloaded is the run loop, right? That's the only one that's automatically reloaded.
No, none of them are being automatically reset, right? I mean, as of this moment right now.
But automatically loaded. There's two that when I there's two ways I think there's three ways the programs can be loaded. One is that they are manually loaded when you're calling them as an instruction.
Yep.
Right? Or as an action. Secondly is when you collide with something, it will be loaded as the interrupt. And then the third is that when you call the run loop, which is actually, well, I guess, the step function. No, when you call the run loop, so there's two ways to do this. And this is the thing I was wondering about. One is that whenever you finish anything, you reset back to running.
Mm-hmm.
The other option is that whenever you finish running, if no one tells you to do something else, you clear the running field, and when it's time to run, it basically does a get running or run loop.
You'd clear everything?
Right, so when I finish running my program, so when I run off the end of my buffer, right, so go back to the code. So there's this get next index thingamajobber, right?
Yep.
So here it says, if I run off the edge of the thing, I load program first, right? I basically have a policy that says, after I finish this instruction, advance my index. If my index is invalid, load the first program now.
Mm-hmm.
Right? And that will essentially do perform this current instruction, and in the same clock tick, reload the default program.
Mm-hmm.
So basically, that's doing a post-update, post-check. The other way to do it is to do a post-update pre-check, right? So when it says next action, At that point, I check and see if the index is out of bounds, and if it is, I fault and load the first, and go back to loading the running program.
Okay.
Do you see there's three? This is actually useful to think through, and I think this is actually how a real processor works, right? Is there's the performing the instruction that's called for, which may result in all sorts of other faulting behavior interrupts and things like that. If it does, or a jump, or right, that's basically what right. These are basically we're talking. We get to redesign processor architecture, Daniel. Okay, let's.
Yeah.
All right. The program, and then so there's executing the current instruction. There's fetching the next instruction, and then there's faulting if that program is not, if that instruction is not available. So from a realism perspective, it would be nice if the step of jumping back to reload the program was its own action that took up a tick, right? Jumping back to the top of the loop is an instruction. It's not a freebie.
Is it? I mean, like, I guess if we're thinking processor architecture, sure, because in processor architecture, everything costs something. But when we think of what makes sense for this game, like, I don't know. I mean, we're writing the rules. You can write them either way. But...
Well, the goal is to try to transparency and modeling reality, right? The goal is to try to avoid magic and like the whole purpose, the premise of this is that high-level event-driven programming should look like low-level electronic circuits.
Okay.
We're trying to get rid of all the crap in the middle that confuses the issue, right? That's one of the visions of this. So let's think that through. So the case where you manually call a jump and it takes an instruction, that makes sense. That does take a tick, and that works the way a processor does, and that works the way the visual does. The case where you hit a and so the idea would be that visually the way it would look is you run off the end, and then the selection button jumps to the name first, and the instruction is load or run, right? I tried changing first to run, and everything broke. I don't know why. I should file a bug for that if I haven't. But that it should highlight run, saying this is the running program, and in fact, when it's empty, that's actually the thing that should be highlighted too. Is it's going to try and load an instruction, and if there is none, it'll just sit there and keep loading the program and not actually do anything. So that's actually what we're thinking through. The start case, if we get a blank system with no functions, the thing that would be highlighted is the word run, the label. And then when it successfully loads the run program, it would then highlight the next program to be executed, or the next action to be executed. And then, which is slightly awkward in that it means, but that would mean that when you start up and you hit run, at first nothing would actually happen except the cursor jumping, which seems a really bad user experience, right? If nothing happens on the first tick. Which would mean what you would want. I'm trying to think through what would be the most physically logical that would also produce the right user experience. It may not be possible, but that would be one. So it would be where when you load the program, you're in the run program, and you have an empty slot saying this is what I want to do next. If I click or drag something into that slot, then that would be highlighted. And then if I hit step, that method should be executed immediately. Right? That would be the optimal user experience, at least surprising. And that feels like that the program counter is pointing beyond the end already, waiting for something. And if there's something there, it'll execute it. If there's nothing there, it will fault and reload. But that would imply that if I am running, so several scenarios here. So let me, is this useful or am I rat holing?
No, it's good for me to hear what you're thinking. The one thought that I have right now is that I'm thinking that if if going back to the beginning of your loop, going back to the beginning of the program takes a tick, then our discussion earlier about the most efficient solution, well, I mean, I guess it is still the most, like the solution in David's program, where it's just forward and right. Suddenly, I mean, the ticks would increase in order to continue to have the most, and I guess this is accurate, because it forces you to think about more, but it would increase the number of ticks, like the actual ticks required to solve the program, using the most efficient developer version. The ticks would increase by, what, 100%, basically?
Because the call to, yes, this is the call to, right, and this is, wow, this is a really fascinating question, right? What is the price of a context switch, right? And in fact, I've had programmers get into fights over this with me in real life, right? Like, yes, you should always break your functions up as small as possible so that they're clearest and cleanest. It's like, and performance be damned. And no, you've got to write the efficient code that does what it does, even if you write really horribly ugly hacks in order to unroll loops, right? I remember doing the first round of performance testing tools at Apple, and loop unrolling was a really big deal. And so it's an interesting question. What would the right solution be? The right solution would be, like, if we're doing our own hardware, you want this is a hard problem. I don't know if there is a good solution to it, right? Is that well, actually, the right solution is, if you know the context in which you'll be evaluating, you can do compile time loop unrolling rather than runtime loop unrolling, right? Is that you know the size of the loop or the number of iterations or things like that, and therefore you can pay the penalty at compile time and not have to check and do the context switch. I mean, this is basically function inlining, right? I mean, because even if you do iteration rather than recursion, or if you do tail recursion, you still pay a price for that tick, right?
Yeah.
Yeah, I think actually going with realism feels like the right thing to do, because then you can actually have that conversation that you can actually discuss. This is a well-known problem in computer science, called context switching, and there's different tricks to reduce it. And so I think that feels good. It feels like the right kind of bad. It's like, yeah, it's a bummer that like the pure solution is inefficient, but that's life.
Yeah.
And you can decide, okay, is it worth adding some more bricks to reduce the number of ticks, right? Unload, and say our loop size should always be 2 steps, and we take the hit on the interrupt when it's wrong. And that's actually the right kind of problems people should be having with this system. Okay. Interesting. So let's see if I can enumerate the cases here. So the case where we start up, there's a case where we are inside a method or a program. There's a case where we're at the end. Startup. There's a case where it's empty. or full, because we're inside a program, we're at the end of a program, and there's a case where we get interrupted. Let's think through the interrupted case first, because that's actually one of the more interesting ones. Most programming languages pretend that interrupts never happen.
Okay.
Right? Exceptions are this horrible, ugly thing that violates the computational model. This is a good time for another little rant, if you're not too tired of them yet.
Nope.
So the hour of code, the traditional form, is based on structured programming. Right? This was the big invention in the 1970s that, hey, rather than jumping randomly around memory and trying to keep track of everything, let's organize our code into these little blocks called subroutines that we jump in and jump out of, and they have a nice clear sequence. And then we add things called conditionals that say only jump at these specific ideas, and we have loops that iterate over things, and so you get for loops and if statements. Mm-hmm. And that was a huge innovation, over just random spaghetti assembly, and that led to the famous goto wars of the 80s, where people said, because before everything was a goto, that's all you had. Mm-hmm. And so the structured people tried to stamp out gotos with religious fervor, and there was a pushback and saying, no, sometimes goto is the right thing, and no, we'll give you a break and continue, and that's enough. No, it's not enough, and on and on and on. But the reality is that error checking and exceptions, which became long jumps in C, are kind of a throwback to these gotos. And my hypothesis is, and the mantra of structured programming was sequence, selection, and repetition. Is that everything should be a sequence or a loop, or it should be a select statement or a conditional. It should be a sequence of instructions which you can repeat in a loop, or you jump, or you make decisions based on conditionals. And that's how you do everything. And that's what the original hour of code grandfather, the Logo language, used to teach. And that's exactly what the hour of code still teaches today for their introductory tutorials. And Seymour Papert, the guy who invented Logo and started all this, wrote in the 1993 editions of his book, like, that was actually a bad idea. Or I'm really sorry that people got the idea that that's what we wanted to teach. No, we want to teach constructivist approaches to learning, and we just use structured programming because that's all that we had. And now we've kept the structured programming and we've lost the constructivist approach. That's what we're trying to solve. So when I was studying all this a couple years back, I realized that I don't really believe in sequence, selection, and repetition anymore. What I believe in is dependency rather than sequence. I want to be able to say this thing depends on that, this thing requires that, and the sequencing, the serialization of sequence is not something I want to worry about. I want the system to handle for me. And I say that do this, and then do all these things, and when it's time, do all these things. Now, with our turtles, they're pretty linear and sequential. Each of them are. So we may not be able to get around for that. The second part is effect, like knowing who's affected when I change this thing, being able to figure out where pointers are mucking around things. And then the third is exceptions or events. And the idea is, and this is a hard thing, and maybe it's too hard, but I was game boarding this with Rohan. The idea was, no, let's actually build an interrupt table. And the idea of an interrupt table in a CPU is a really interesting thing, in that what it says is, before you do the next action, you check for an interrupt, right? You still there?
Yep.
And so the idea is that the interrupt is not a program you load, as I was thinking, or it is a program you load, but it's not a separate tick to check for interrupts, right?
Right.
It is the first half of the tick, before you do anything else, you check the interrupt status.
Right.
Which implies that the right architectural way to do that is, rather than calling load program when a collision, what the collision do is should set an interrupt property on the sprite, with the value being either the program to be run or the list of interrupt names to check. Right?
Okay.
Right. In the real architecture, that's how things do it. And then at the beginning of the tick, before we do the next action, we do a check interrupt.
So,
and let me just so I'm not saying this is the right way to do it. I'm saying this is the natural way to do that. And does that make our problem easier or harder?
well,
and so if we did that, then the other way to think about it is that at the end of, if we run off the end of a loop, rather than loading a program, we set an interrupt which is, run, right? Return to main or whatever. And so this is the good news is that this feels like a really interesting hard problem that we're running into for practical reasons. Which, if we can come up with a way to solve this, we might actually, without taking more than 5 or 10 minutes, we might actually be able to say something quite profound about how to integrate run loops, interrupts, and subroutines into a coherent architecture. So can I keep riffing, or do you want to interject something?
No. Go. I think you're good to go ahead.
Let's go. Okay, good. Checking for interrupts. What we want to be doing then is, so we have the idea of an interrupt table or an interrupt property that we're checking at the beginning of each tick. And so the sequence would be, in that scenario, first check the interrupt table to see if we've been interrupted before we do anything. If we have been interrupted, then run that. Forget what else we were going to do. So that's option A. Option B is check the next action to see if it's a valid action. And if it is, do it. And at the end of that, advance the counter, regardless of what happens. Because I don't care if you've been interrupted or not. That's not my problem. I'm just doing the action and advancing my counter. Sorry, advance the counter if it's not reset by a load. Mm-hmm. Right. So A is interrupted. B1 is normal action. B2 is load action. C is there's no action, in which case we go back and run. So that the interrupts are special. The run method is the default, and it's hard coded in not in the it's not hard-coded in the action sequence. It's hard-coded in the in step, right? Or this is almost like a thing outside of step, or right where step says, for each it's a the name step and tick are getting right now. Our step function calls tick and then decide.
Right now, our step. I'm not sure right now. Hold on. Yeah, tick and then decide.
Okay. The canonical names for those, I believe, would be fetch and execute.
Okay.
That sound right?
Yeah.
That feels like, I mean, I started suspecting this a while ago. I'm really building a processor simulator.
Okay.
And Pat's, my friend in Australia, is actually looking at, could we actually build a real processor that implements this architecture? If we get, someone gives us $500,000, that's probably what we'll do next. So, and then, so if that's the fetch and execute phase, so let's see if we can get the right metaphors for if this helps our metaphor. So we have so phase A is check interrupts. Phase B is fetch and so it's either fetch and execute, or it would be fault and run. Right? If we can't fetch an next action because there isn't one, then we don't execute. We fault and run. And I'm trying to think. This feels like this ought to be a common design pattern, but I can't think of an example of that. Unless it is like booting, but you don't really go back to the bootloader when it's more like if you are in a Unix program and you fault, you go back to the shell.
Yep.
Right? You go back to the REPL.
Mm-hmm.
The difference is we have a default program that is running there, which is not a REPL. So anyway, that feels like a cleaner architecture for describing these behaviors. Check interrupt, fetch execute, fault to run, which means that the are if I don't tick, no. Let's go back. Let's think. Okay, I'll take that back. On tick, we actually break up tick. So tick is so execute should always be the same because everything can be happening. So on tick, we can either load interrupt, fetch action, and fetch and perform action, though we don't execute it, or load, run, perform first. So the idea is that our is that right? I'm torn between realism and user experience, and I don't know if there's a good choice because it gets back to the same thing before. Is it feels more realistic that a load should take up a tick, and you have to sit there and watch it because it hurts to get interrupted. But that kind of implies that every time you run, I mean, you can do a prefetch the first time when you start up the computer that it loads it, but it does imply that every time you have a blank run loop and add something, the first time you click step, it'll do nothing. And that just it'll be experienced as a bug.
Mm-hmm.
So I'm reluctantly going to err on the side of experience rather than realism and say that we have a fused load fetch. Right?
Okay.
Our load instruction automatically fetches the first element. So that means that the phase. So the actions are, and strictly speaking, yeah, and so the options are load and fetch interrupt if one has been set. Fetch current program, fetch action from current program, or load and fetch from run, which implies that if there's an interrupt, for an interrupt you do lose a tick because you tried to perform an action that failed. You perform the action, it faulted, it set the interrupt flag, and then end of turn. And then next turn, it'll do a load and fetch and interrupt, which actually makes perfect sense.
Mm-hmm.
And then the default state of the sprite, which I like, is nothing is running, and it'll just fault and do a load and fetch of the run loop.
Okay.
Now, that and so what it implies is that our load program, right. So this does actually solve our original problem from way back when, which is what happens when you throw an interrupt. You don't actually set the running property, you set the interrupt property. And when you check that property, if it's non-zero, then the program object calls load program. So the sprite has a property interrupt.
Okay.
And the tick function checks interrupt.
Okay.
Right, and then it knows when it loads, and so load program actually does three things. It sets the current active program, the sprite's running property. It resets the index to 0, and it returns the first action of that program.
Mm-hmm.
So it's actually kind of like fetch program rather than fetch action, if that makes sense.
Okay. I think so.
And if we do that, then to be fair, when we manually tail call if we manually invoke a program at the end of a thing, then that will actually load and fetch the first instruction of the next program.
Mm-hmm.
So basically, we're just going to say, we're going to assume we have a zero cost fetch consistently.
Mm-hmm.
Is that we can we have a look ahead of some kind that allows us to default it,
Mm-hmm.
and so we trade a little bit of realism for consistency and user experience. And when we're sitting here a year from now trying to design our own process, say, oh crap, we've got millions of students who expect it to be a zero-cost fetch. How do we deliver that in real hardware? But I can live with that problem if we succeed enough to have that.
All right.
Okay. I feel like we're going sideways rather than forward, but I feel like this is good. Good cleanup.
Right.
I feel like this makes the code better and easier to manage and easier to understand. And it also implies that I think it'll also make it easier to interrupt well, I don't know if it'll make it easier to do anything, but it feels like it's better factored. Let's leave it at that.
Mm-hmm.
So it's getting to the end of my day here. You feel like you got enough to chew on?
Yes, I do. Let me run over these and try to write down actionable steps based on the conversation that we had.
Sure. You want to put up your screen so I can see what you're writing?
Sure. Okay. So
I think this is the tick function.
Okay.
Tick method. Sorry, I gave you a lot of grief over the word function last time. I should try and be at least really consistent.
So
first step
for interrupts, right?
Actually, I think there's even a simpler way to describe this. Fetch interrupt, else fetch action, else fetch run.
Okay. So, and then collision, Sprite collision is Sprite put interrupt, right? Or, if...
Actually, no, it should just be Sprite put interrupt, period, right? Because it only gets called if, after our last exercise, it only gets called if it actually got interrupted.
No, I believe that Sprite.interrupt still has some logic on it.
I know, but why? I don't think it needs it, right? Because we said it only should call if this actually was obstructed.
Oh yeah, you're right. You're right. Right. So Sprite.collision, all it does is set the interrupt property.
Well, actually, what it should do is figure out which keys, if any, are valid. Right. That's the to-do that wasn't done there yet. And you give it a key, right?
Right.
Right. You pass an object, and you call, on the obstruction you call, but if I put interrupt key, and we'll have to, you get to figure out how to get the key from the obstruction.
Right. So some kind of key there.
Mm-hmm.
So the tick, when it goes to fetch interrupts, it looks like check every sprite for an interrupt.
Don't. The tick is on the program, right?
Right.
The program only has one sprite. Oh yeah, right, yeah. Break interrupt, and then, basically if sprite get interrupt, sprite load, then load. Load program. Actually, we should do what we should probably define load program. That would actually be useful. What load program should do, or fetch program. Sorry. Fetch interrupt should be fetch program. I think that actually should be right. That should actually be at the program level. Programs level. Programs.fetch program, I guess. Actually, no, it's actually an action. We decided those would all be under actions. Let's try it and see if we can make that work.
Under actions?
Right. Remember I talked about relabeling the buttons as actions? Moving them all down there. So actions fetch program should be Sprite set running to key. Then and then for the we're back where we were before. Do we actually need the programs list? Maybe tick doesn't need to be on the programs level. I stand corrected. Right. So programs.tick is then program should be programs find child key.
Okay.
No, programs set running key first, or either order doesn't really matter. So that was correct there. Sorry, programs find child or sprite set running. Both of them have to happen.
Okay.
And then actually, I guess probably sprite set running key first, and then programs find child key. Programs find child key. Next action, get next action, right?
Okay.
No, I mean that should be at the end of the previous one, as a get, dot get.
Oh.
Quote next action.
Okay.
And then next action. Oh wait, no, we forgot. Oh, sorry, no. It should be something like p equals programs find child key, p dot, and before we do p dot get next action, we have p dot, call reset, p dot call reset index, and again, I think we said call next action. Yes, that looks right. And then fetch action. Okay, so fetch interrupt then just becomes fetch program sprite get interrupt, right?
Yes. Right. And then somehow the inheritable thing with the interrupt key, we have to find a way to make somewhere there has to be intelligence on that interrupt key and figuring out the appropriate program for it.
Oh, that's trivial. I'll show you. Sprite collision, you pass the obstruction,
mm-hmm.
and then you do keys equals instruction obstruction dot labels. And then you basically go through the list of keys, and then so we do it the other way around then. We put interrupt sprite collision obstruction, sprite put interrupt obstruction dot labels.
Right. And then fetch program needs to have some kind of intelligence.
No, the fetch program shouldn't have to deal with the interrupts. There should be under fetch interrupt. So fetch program should just take the key. Then that needs to be 2 lines, right? It needs to be, find interrupt.
Okay. Yeah. Whatever that key is.
Well, from sprite get interrupt, right?
Right. So then find interrupts.
And then you just fetch program that function. Yeah.
Has the
Right. Well, that actually probably will call sprite. Actually, it would be fetch program. Actually, it would be logic. Right. Logic to just check. Basically it's going to be like programs dot has child, right?
Yeah.
Return the key. In fact, would it be... No, it's easier just to pass the key and pass the pint down, right? Yeah. Right. And find interrupt, since it takes in the program argument, you would actually do the get interrupt inside of the find interrupt, probably. So it'd be key equals find interrupt.
Uh-huh.
And then, if key, fetch program key.
Oh, okay. Yeah, I see.
Else, fetch action, right? And even find interrupt, you don't need to pass the Sprite because you can call Sprite get interrupt in find interrupt.
Right. So then for fetch action, basically all we do is we get the next action, and it should be run.
You get next action, and we should advance count and advance index. It's two things.
Right. And then for run, we should
just fetch program run.
Oops. Okay. And that does cost something right there.
Yes, but fetch program run, right? The only it doesn't because it just program tick essentially this is returning an action. Right? At the end of tick, we have an action that we then perform.
Yeah.
In some sense, you could say this is actually the top-level next action method that we're doing here. But I think thinking of this as a tick is probably a good because everyone was basically saying you're asking it to return an action, and by effect, it's also resetting the state.
Mm-hmm.
And basically, action equals this. Well, either the whole thing returns an action, or each step does something, and if there's no action, then it does the next thing, right? So the else's become, if not action, do this. I'm not sure the right way to structure it, but
right.
And yeah, but I think that's to be clear is that this returns an action, or and then this is all. I guess we could call that fetch action, that method, right?
This one?
There's all these fetches there.
Yeah.
Those are all kind of or find action, or because basically the tick basically needs to find the action and then perform it.
Right.
So not that one. That would actually be fetch program run. Literally, it's just fetch program run. You don't even need the else fetch program. Okay, yeah, that's all that it is there. Yeah. In Ruby, this would be action equals fetch interrupt, or fetch action, or fetch run.
Right.
Okay, I think you understand.
I think I do.
All right. Thank you.
Yeah.
It is cool. It is slow. That's life. That's what happens when you're doing awesome stuff badly.
Yep.
So tomorrow morning, so I'll be, I don't know, you planning to work tonight, or are you going to try and take the evening off and get some rest?
I'll be working for probably another 40 minutes, but that's probably it.
Okay. So if you can push something up so I can take a look at the branch in case I have some time tonight, I can take a peek at it. If not, we'll pick it up tomorrow morning at 9:30.
Okay. Sounds good.
Right. Thanks, Daniel. Take care.
Mm-hmm.
Bye.